So there are four ways to solve a system of equations that we're going to deal with. And remember, a system of equation is multiple equations with multiple unknowns. Number one, we can do any methods of graphing, which is what we did yesterday. Number two, is going to be to solve by substitution, which is what we're going to do right now. So we're going to kind of stick, we'll learn out the other ways here in a bit, but to solve the system by substitution, remember we need two equations with two unknowns. So here we go. We're going to do this by example, but again, this is called substitution. Number one, 5x plus 2y is equal to 5, and x is equal to 18 plus 3y. To start, on the right side, I'm going to kind of put the reasons down we do. We want to put one equation, one of the two equations that we are given, into x equals or y equals form. And as you can see, we already have that. We have the second equation as an x equals. So that's a check. Then here's the trick behind substitution. We are going to substitute the expression for that variable and what I mean by the expression for that variable, I mean the thing on the right side of the equation when you solve it for the other variable. We're going to substitute the expression for that variable into the other equation, or in this case, into the first equation. So what we have is this thing is going to go in and replace the x. So my next equation is actually going to be to write the first equation, 5x plus 2y equals 5, but write it instead of 5x as 5 times 18 plus 3y plus 2y is equal to 5. Then step 3 is to solve, for the first variable, meaning the first variable that we're going to find. So that's this step right here. Let's go ahead and multiply 5 times 18. You get 90 plus 15y plus 2y is equal to 5. Well, I don't know, I put 17, sorry. 15y plus 10y. No, plus 2y. Because 15 plus 2 is 17. Wow. 17y is equal to negative 85, and y is equal to negative 5. Okay, we have what y is. Then, finally, to find the other variable, substitute the first variable into either original equation. Well, I'm going to take this and I'm going to substitute it right in here because it's already solved for x, and that's going to make things easier. So x is equal to 18 plus 3y plus 3 times negative 5, which is 18 minus 15, or 3. Finally, I'm going to express my solution as an ordered pair, x comma y, 3 comma negative 5. I'm going to put that in set notation. So let's try this with some more practice. Number 2. 3x minus y is equal to 11, and 5x plus 7y is equal to 1. I'm going to take these 4 steps and kind of carry them down here so we can follow them. You should be looking back up the 4 steps too, and you should get a very good intuitive sense of why these work as we go through this. So as we bring these down here, we realize the first step is to put one equation into x equals or y equals form. Well, if we scan our variables, we have 3x, negative y, 5x, and 7y. Probably the easiest one to target is this one. So if I take that first equation and I move the y to the right side, I get 3x is equal to 11 plus y, and subtract 11 and I would get 3x minus 11 is equal to y. Okay, Now, we're going to take that and substitute that expression in for y in the other variable, or the other equation. So I have 5x plus 7 times 3x minus 11 is equal to 1. Then keep solving. 5x plus 21x minus 77 is equal to 1. I get 26x is equal to positive 78, or x is equal to 3. Now we find y. Now I'm going to take this and I'm going to put it back into this form because that's going to make it easier to figure out what y is. So I have 3 times 3 minus 11 is equal to y, which is equal to 9 minus 11, or negative 2. And I have 3, negative 2 as my solution. We can do these when the numbers aren't as clean. Here's an example of that. X plus 2y equals 12, and 3x minus 8y is equal to 16. Well, when I have this, if I look for a variable to solve for, maybe the easiest one to go for would be that first x. So if I take that and say x is equal to, I could have negative 2y plus 12, and take that and plug it in for x. 3 times negative 2y plus 12 minus 8y is equal to 16. Multiply, I get negative 6y plus 36 minus 8y is equal to 16. Combine like terms. Negative 14y plus 36 is equal to 16. Subtract 36, negative 14y is equal to negative 20. And divide by 14, I get y is equal to 20 over 14, or 10 over 7. Definitely workable, so don't freak out that that's a bad number. It's okay. Put it back up in here. We get x is equal to negative 2 times 10 over 7 plus 12, which is equal to negative 20 over 7 plus, and if I change 12 into sevenths, that would be 84 sevenths, and I get 64 sevenths. So my x was 64 sevenths, and my y was 10 sevenths. Number 4. I have y is equal to 4x minus 5, and 8x minus 2y is equal to 20. This is already solved for y, so I'm going to take this right side and plug it in for y here. And I would get 8x minus 2 times 4x minus 5 is equal to 20. Or 8x minus 8x plus 10 is equal to 20. And if I simplify the left side, I would get 10 is equal to 20. And then we kind of stop because our variables are gone. So I want you to make a note here. Variables are gone. What we are left with is not true. 10 is not equal to 20. What we are left with is never going to be true. So we can say no solution. This also means that these were parallel lines, since parallel lines never cross. Okay, number 5. I have 2x minus y is equal to 1, and 3y plus 3 is equal to 6x. Well, the easiest thing to do here would be to take the first equation and solve it for that y. So I'd get 2x minus 1 is equal to y. Check that for yourself. Then we're going to take the 2x minus 1 and substitute it in for y. So I get 3 times 2x minus 1 plus 3 is equal to 6x. 6x minus 3 plus 3 is equal to 6x. If I simplify the left side, I get 6x, and if I simplify the right side, I get 6x. Now, 6x equals 6x. That we can stop at. I could say that this is always true. Since it's always true, my answer is the equation. You may say, which equation? Well, they're actually the same equation. If I were to take the second one and solve it for y, I would get 3y is equal to 6x minus 3, and y is equal to 2x minus 1. And it's the same thing as what the other one was. So that's my answer. Y equals 2x minus 1. Then I do an all xy in parentheses, colon, such that, put that in set notation. And that's it.